Hi everyone, welcome back to Noskrit, and in this video we'll talk about sync versus async communication and request response architecture versus event driven architecture, right? So let's see what we are going to discuss in this video. So these are the things that we will be discussing in this video, that is communication between subsystems, right? So we will look at the number of ways through which we can communicate within the subsystems in a network, right, in a system actually. And then we will see what is the request response architecture. Then we will see some challenges that we can face in request response architecture. And then we will see what is the need of event driven architecture, right? Why do we actually need it? So let's start with the first of all communication between subsystems, right? So within the system actually we can communicate with two ways actually. There are two ways. There is a sync communication, that is synchronous communication, and there is asynchronous communication, right? Whereas synchronous communication actually, in this particular communication, this particular type of communication, so services actually communicates with each other using requests, right? So some service will send some request and then it will receive some response, right? So request is there, right? Request is there in the synchronous communication. Whereas in asynchronous communication actually, services do communicate with each other using events. They do not communicate with request, right? That means if let's say systems are communicating with asynchronous communication, then in those cases the client will not be actually sending the request, right? Client will be sending something else, right? And we will see that what is that. Okay, so let's first of all try to understand what is actually synchronous communication in detail, right? So here I'll be taking a e-commerce app example, right? So say for example, this is a common repo, right? This is a common repo, or I should say that it's a mono repo. So when we talk about mono repo, that means it's a monolith architecture, right? That means the entire code base of an e-commerce app is within a single service only, right? It's a single service which is handling everything, which is handling, let's say, payments, which is handling, let's say, order management system, which is handling, let's say, user authentication and authorization, everything, right? So I'll be basically taking three use cases over here, right? So let's say this particular service actually holds a code to sign up a user, right? So maybe within this service, maybe somewhere we will be having a code to actually sign up a user to log in and log out, the code of login and log out for a particular user, right? Then in the similar service, in the same service actually, in the same code base actually, we will be having a code to list available products also. Let's say, and as you see in the Amazon website, right, we can list out the product. So we have the same code, we have that code in the same service actually. And let's say we have another code, which is code to purchase a product, right? So we have the code to purchase a product in the same service, in the same code base, right? And let's say we have different databases, let's say user database, then product database, and then order database, right? And as per the request, this particular code might be using this particular database, this particular code base might be using this particular database, and similarly this particular code base may be using this particular database, right? But this is a simple monolith architecture in which the entire code is written within a single code base, right? Now let's say tomorrow if we have another kind of request, right? So say for example, let's say tomorrow if we come up with some other kind of request also, that means we want to have a code to list the products ordered by a particular user, right? So this is a different maybe use case, right? So we want to have the code to list the products ordered by a specific user, right? So let's see if there are any challenges in this monolith architecture, right? Let's see. So if we want to implement this particular scenario within this particular use case, right? Within this particular code base. So we can simply do that, right? We can write that particular code, and this to achieve this particular use case, what will happen is I will have to first talk to this user DB, right? Because I will have to check whether that user exists or not. So I can simply call this particular DB, and then after making a call to this DB, right, I will come to know, okay, this particular user exists. And then this particular in this particular code base, we can have another query which will actually go to order database, and this order database will actually find, okay, whether whatever the orders are there for a specific user, right? And we can fetch them, right? So there are no request calls within that system because it's a single system, it's a single service, it's a mono repo, it's a common code base, right? right? Because single code base is there, right? So we can simply make this DB call to actually verify the user, and then we can actually call this order database to actually fetch out the number of products related to a user. And maybe if you want to see the details of those particular products, then in that case, maybe I will have to call this product database also to actually fetch out the detailed products, details of the product, right? Means details of the product in detail, right? Like what is the product, what is the name, who is selling it, right? And what, like other things also, right? So there is no problem. When problems will come when we will maybe have to scale this system, right? There in that case, maybe some complexity will be introduced in the system. Maybe it will be difficult to scale this system, might be, right? These kind of complexity come in. But if we really want to add this feature to this particular data, to this particular service, then there is no problem at all. Right? Okay. So but in today's modern era, we generally don't follow this monolith architecture, right? We mostly are following, companies are mostly, moving their code base to microservice architecture. So let's say if we want to implement this particular use case, how microservice architecture will look like. I am not this. So see, right, as of now, I am not telling you what is synchronous communication. I will tell you synchronous communication when I will be talking about microservice architecture, right? But I told you this monolith architecture before moving on to microservices, so that you don't, you understand everything. Okay, why this microservice architecture? Now let's see if we want to implement this particular use case in microservice architecture, how would it will, look like? Let's see. So if we want to implement this particular use case in microservice architecture, then we will have to break down these services into different services, right? So I told you like the entire service, entire code base was taking care of the user management also, the product management also, and the order management also, right? So but in this case now we have broken down our services into user service separately, which will be having its separate database, then product service separately, which will be having its product database, and then order service separately, which is having its order database, right? Okay, now let's say if some other service comes into the picture, let's say some new feature comes into the picture, and for that particular feature we want to really write out a new service completely, then how and what difficulties we may face. Let's see. So let's say now this particular feature I want to write, get list of product ordered by a user. This is the same feature that we were talking about. So one thing you might be feeling over here, that why we are building a completely new service for a small feature. It's just an example, guys, right? Definitely if I talk about in real world system, definitely I'm not gonna keep this particular feature in an entire complete different service. No, not at all. But it's just an example. I just want to show you something through an example, right? That's why I'm taking this particular feature into a different service, right? So let's say I want to write a completely different service for this particular feature, which will actually list out the products ordered by a user in a microservice architecture, right? So how the communication will happen, right? How this particular service will interact with different services or different databases, right? So that it actually fetches out the list of products ordered by a user, right? So let's see that. So what will happen is, I'm calling it as a service D, let's say, right? So what will happen if this particular service wants to get the list of products for a specific user that the user has ordered? How this service is gonna make request calls, right? So let's see that. So what will happen is, this service D will try to access this database, right? This service D will try to access this database. Okay. Then this service D, because why this service will call user service, like a user database, because it needs to verify the user. Let's say, for example, you are asking that for the user 101, we need to calculate the list of all the orders, right? So first we need to verify the user, whether a user exists or not. So let's say this service directly calls this DB, right? Okay, now let's say some verification is done. We have got okay, this service actually, this particular user actually exists. Now what will happen? This particular service will actually call this order service, order database, not service. I'm really not talking about service right now, directly database. This service is calling database directly, right? So it will try to call the database directly because order details are there in this database, right? So maybe we will list out, maybe we will get some product IDs, let's say P1, P2, P3. So these are the product IDs that this 101 user has ordered, right? Now, if we want to really see the details of these particular products, maybe title, maybe the product title, product image, maybe these things, right? Then in that case, maybe I will have to call this product database also, right? I will have to make a query to this product database also, and then we will basically get the detailed product of product P1 and P2 and P3, right? So this is how we can interact. We can actually make request calls to these DBs directly, right? But microservice architecture doesn't allow you to call these databases by a different microservice. This is not really allowed in microservice architecture. That means if service D wants to directly call this user DB, this is not possible scenario. This service can't actually call this user DB directly. It is not allowed in microservice architecture. Microservice architecture completely disallows this thing, right? Then how we will make sure that this service D fetches all of these details, right? So let's see that. So instead of calling this database directly, what will happen is, related to the user thing, this service takes care of that user thing, right? So whatever details related to a user you want to get, you need to ask to this service. You can't really call this database directly, right? So this particular scenario will actually force you to make a request call to this service, right? That is completely fine, right? But you can't really call this database directly, right? This is not allowed in microservice architecture, okay? But that's fine. If we really want to get the details of the user, we will have to make a request call. So it will take another request call, right? So what will happen? Let's see. So first of all, this service D will make a request call to this user service, maybe just by sending user ID 101, okay? Then this user service will take this user ID and it will actually internally call this database and confirms all the things, okay, that whether user 101 exists or not, right? And then finally this user service will actually send the response to this user, this service D, okay? So first of all, what will happen is, there will be some request, right? That request will be basically given to this service D, okay? And then this service D takes this request and then makes another request to user service actually to get the details of the user 101. Then basically this user service will internally talk to this user DB, and then it will actually give the response, okay, whether this user exists or not. Now let's say this service D received the response, okay, user number 101 exists actually. Now what will happen is, it will actually make another call. It will actually make now call to order service, because now we want to see the details of details of the orders ordered by this particular user. Okay, so this service D makes a call to this order service. See, this request is still in process. This is not completed because this is the request to fetch out the list of product ordered by a user, and these things are the steps to fulfill this request. This is the first step, then this is the second step. Now the request is made. Now this order service will internally talk to this order DB, and then it will actually send the response back to the service D, right? So service D will receive that response, okay? So maybe it will receive some product IDs, let's say P1, P2 and P3, right? Now let's say if we want to calculate the detailed list of detailed description of these products, then what will happen is, we will have to make another request. So we will have to make another request to this product service, right? And after making a request to product service, maybe product service will internally call this product DB, and then basically it will actually send the response back to maybe the service D, right? And finally, when all these three requests are completed, the first one is to user service, then to order service, and then to product service. When these three requests will be completed, only then this service D will receive some response, okay? No, actually not service D will receive the response, but what will happen is, this client, whatever client, this request is made by some client na, so there will be some client actually, right? This client will be actually making some request to this service D, right? So the request that this client actually made, now this request will actually receive some response finally. So this service D now will send the response back to this client actually, right? So I hope you understood the complete flow. But what are the scenarios in this case? What are the disadvantages of this kind of scenario? Let's try to talk about them, right? Now let's see what are the advantages of and disadvantages of this particular kind of communication, right? So What are the pros? So pros are that it is very easy to understand. Conceptually, it is very easy to understand, because one service is calling some other service. If it gets the response, it receives the response, then it makes another call, then it receives the response. So this is very easy to understand. This complete flow is very easy to understand, right? Now, service D won't need any database also, because we don't really need to have another database which will hold the mapping of user and product, right? Because we are already having some user service, user database, and then order service which is having order database. So if tomorrow some other new use case comes in, so we can simply make the use of those particular databases which are already there. We don't really need to make another database to fulfill that particular feature, right? So service D won't need any database. Now, what are the cons of this particular kind of communication, right? Let's see that. So it introduces dependency between services, right? I will talk about it, like what kind of dependency. Now, if any internal request fails, overall request fails. Say for example, so if you go back and notice here, so this particular single request is actually successfully done when all these three steps are done, right? That means if any of the request fails, let's say order service is down, so this particular request successfully done, you successfully got the response also, but because this user service was down, so this particular request couldn't be fulfilled. That means this service D will send the response error. Error means like service is down or whatever, right? So the request will be failed. Point is that the request will be failed, right? Maybe some internal server you will get 502 or something else, right? Similarly, let's say for example, user service is working fine, order service is also working fine, but right now product service is down. So because product service is down, so what will happen is the overall request will fail. Right? And see, let's say failure is some other case. Failure is not a big problem, right? Problem is when the request is actually slow, right? Because something is down, that is completely fine, because user will actually receive some message. That is not a big problem. But what if this service is down, let's say? So let's say for example, let me just make you understand this point. Let me just remove everything from here first. Now let's say this particular client actually makes a request. Okay, this is a request. Now this service D calls this user service, okay, and basically this user service, let's say, takes 10 milliseconds to complete the request, right? And thereby, like because this is a fast request, 10 milliseconds is not a big time, okay? So let's say this is done. Now this service D basically calls the order service. This is also taking, let's say, 10 milliseconds, not a big problem, right? But now when this user service call is done, when this order service call is done, now when you are gonna call this product service, okay, let's say by any chance this is taking, let's say, maybe 1 second of time. Let's say this is taking 1 second of time. So what will happen is your overall request, which is the original request, this is as fast as the slowest request is fast. Okay, that means what do I mean by like this? So let's say for example, this request will be as fast as the slowest one request is. That means the total time taken by this request will be nothing but 10 millisecond plus 1 second plus 10 millisecond, right? So if any of the request is taking time to get the response, then your overall request will also become slow, right? So that's what I'm trying to say. Okay, that means now see, and until this request is not fulfilled, the same client can't really make another request because he is waiting for that request, right? So that means if your service is slow, then it will actually put some overhead on the system, on the complete system. Okay, so let's see other points of the cons, right? So we discussed about introduced dependency between services. I'll talk about this later. If any internal request fails, overall request also fails. Let's say if some services crashes, if some service is down, the overall request will become down. The entire request is only as fast as the slowest request. I have already told you about this part, that if some service is taking 10 milliseconds, then 10 and then 1. So the complete will be 10 plus 1 plus 10, right? 10 millisecond, then 1 second plus 10 millisecond. And it can introduce lot of dependencies also. So now let's talk about these particular 2 points over here, because I can combine these 2 points in a single one, right? Let's talk about this. So what is the meaning of dependency? Let's try to understand. So today, let's say for example, this service D is actually calling user service, right? Then it is making a call to order service, and then it is making a call to maybe product service. But we really don't know the case. Let's say if user service internally calls some other services also, right? Maybe to fulfill that request, to actually, give you response back for this 101 user, that 101 user exists or not, to actually give the response of this particular query. Let's say service A talks to some other services also. Maybe it might happen tomorrow, maybe not in this particular use case, but let's say you are building something else, you are building some other use case, and you have a scenario wherein some service is calling to some other service, and it might be possible that this service internally calling some other services, right? It is also possible. So what will happen is, let's say if this particular service is down, if this particular service crashes, your entire request will crash, okay, your entire request will fail. Similarly, let's say if this service is slow, and while making call to this particular service, this service actually calls to this service also, and this is slow, that means your entire request will also be slow. Okay, so this is a problem in synchronous communication, because you created a request and then you are waiting for the response for that particular request, and unless you don't get the response of that request, you can't really make another one, right? So that is the problem. So that is the problem in synchronous communication, and I hope you got to know about what is synchronous communication. Okay, now let's talk about what is request response model. So request response model is nothing but it is synchronous communication only. So here I am taking some other example. So this client, let's say, makes some request. Okay, that request will go to some API gateway, right? I already told you about this API gateway in my last videos, right? So this API will gateway take this request and maybe call to this upload service. Maybe you are trying to upload some video on YouTube, right? This is an example of YouTube service. Now you are maybe trying to upload some video. So this request will go, and this request will be passed to this processing server, right? Processing service. So this particular service, what it will take is, it will take that video and it will start processing that video, right? And it will take some time. So you must have experienced, if you are if you have maybe uploaded some YouTube on video some on YouTube channel, or maybe like maybe on some other platform. So what happens is that until that complete video is uploaded, you don't get the response. You only get the success response when the complete video is actually processed or uploaded, right? So that request is still in process. You still haven't got any response, because it might be possible that while processing your request, the service may fail, right? Maybe your file is having some problem, right? So the request will go to API gateway will take that request to upload service, the upload service will take that request to processing service, and then finally that processing if the processing service is completely done, then this particular request will go to notification service. Your request is still in process unless this is completely processed, and as soon as it will be processed, then only you will get the response. Fine. Now the problem here is that, say for example, you made a request. This request is still passed to this API gateway, then API gateway pass this request to service A, and then service A also passes this request to processing server, and maybe now processing server also pass this request to notification server. Now let's say by mistake, by any chance, notification service is down, right? So your upload service fulfilled the request successfully, your processing service fulfilled the request successfully, but because of notification service, your request couldn't be successfully processed. So what will happen is, you will receive some error code, right? Again, your entire request will fail. Okay, and in that case, the request, you will receive some response of error, maybe some bad request, or maybe some some internal server error, whatever. It depends on what kind of error actually happened, right? So this is a problem in request response model. If you have so much complexity involved, if you have lot of dependencies involved within your system, then if even a single request fails, your entire request will fail. That is the problem. Okay, I hope you understood what is request response model. Now let's try to understand what is actually, so first of all, let's try to look at some challenges of this request response model. Okay, so what were the challenges of this request response model? That if upload and processing service request completes task successfully and notification service fails, so what will happen? So first of all, client receives failed response because a request actually failed. Then he will try to perform the task again, and which ultimately increase the response time. Okay, because if the client is actually making the request once again, it will definitely increase the response time also, and it will increase the load on the system also. Okay, because you are trying to re-upload that particular video or maybe some other thing, right? Fine. Now, next thing is that upload and processing service would have updated the database. So when you are actually uploading something, so upload service will have something, some database related to it, because I told you that each service in microservice architecture has its own database. So upload service will have its own database. So when upload request is completed, so upload service would have updated its database. Okay, something has been uploaded, maybe ID number 101, this video has been updated with title, maybe some description, and that's all, right? Similarly, processing service would be also be maintaining some database, its own database. So what will happen is processing service would also have updated its database. Maybe this particular video is processed at this particular time, right? So upload and processing service would have updated their databases now, right? But because notification service actually fails, the request at notification service actually fails. So what will happen is, so whatever changes happened due to the upload service and due to the processing service in those two databases, you will have to, like revert them. You have to revert them. So again, you will have to go to the databases and talk to them of processing and upload services. Okay, so that's the another overhead which you will put on the system. Okay, because request couldn't be passed, and this is the extra work that you have to do. Fine. Now, complexities are involved in this model because if it needs to be scaled. I already told you about this part in earlier phase, right? Now let's talk about this part. Now let's say, for example, this is also one of the drawbacks of this request response model. What is that? So let's try to read this. The request response model is inefficient when the server wants to inform the client about events occurring in the backend. Let's say something is occurring, right? Something is occurring in the backend, and you want to now update the client. See, so try to understand this. Client is not requesting something from you. You want to update to the client. You want to send some, event or notification to the client. This is not possible in request response model because client has to request something, only then request response model will respond something. This is not possible, right? So whatever notifications you receive, whatever, maybe not, I'll call it as notification only, whatever notifications you receive maybe in Instagram, maybe on Facebook, maybe on some other platform, whatever, YouTube, whatever. So that is not a request response model. That is something other model. That is some other model, maybe PubSub model, maybe, event driven architecture or something else, right? But that is not request response model, because client, you are not requesting YouTube to send notification. They are sending you the notification. Backend is sending you the notification, right? So if you want to achieve this particular thing, we can't achieve it in request response model. So I hope you understood what is request response model in detail. Now let's talk about what is event driven architecture. So first of all, in event driven architecture, we don't have the concept of request. That means client actually doesn't request anything, right? So what happens is we send the events, right? So what will happen is, let's say client wants to request something. Okay, so what will happen is that particular request will go to this particular service. Fine. And let's say this particular service will basically produces an event. This particular service will produces an event, and that event basically will go into some specific topic. So this is a topic, right? So we call that particular thing a message. So your request, earlier we were calling it as a request. Now we will be calling it as a message. So that particular message will be going to this topic. Okay. And this service B, maybe let's say any service, let's say service B will consume this message from this particular topic. So this is an event broker. So what happens is, so earlier whatever request was being made, so we will try to assume that we will take that request, and we are simply taking that request and pushing into this particular queue. It's a kind of queue. Try to understand this as a queue, that it's a queue, and we will basically try to push that particular request into this queue, right? Now whoever want to take this request, take this. Whoever want to take this request, take this. You are consuming this. You are consuming requests from this particular event broker. Now let's say, for example, so that the earlier request which we made, this particular message is still not processed. It's still not processed, but this service A can still produce another message. Message 2, right? Maybe let's talk about this in this fashion. Let's say you were requesting earlier user 101 ID. Right, whether user 101 is exist or not, right? So what service A will do? Service A will produce an event with, let's say, user ID 101. This particular message will be consumed by this, let's say, service B, which is a user service, Okay, we are not really taking care when it will consume. We just have simply pushed the event. That's it. Okay. Now, at the same time, this request is still in process. At the same time, what we can do is service A can produce another message to this event broker, and this will be, let's say, event 102. Now, service A has still not received the response of that earlier request, and like having this particular request in still process, what will happen is this service A is producing another request which is of ID 102, right? So this kind of architecture actually makes the client free from the request and having to wait for the response, right? So in this particular case, you can actually push any number of messages onto this event broker without actually having the response of your earlier request. So this event driven architecture actually makes the things easier for you, makes the system actually less overhead. Okay, so I hope this is clear. So we are not going very much in detail, but yes, this is how this event driven architecture works. So you take a request. So that first of all, this we should not call it as a request, we should call it as an event. So we take that event, request here is termed as event, right? So you take that event, you push that event into some event broker, into some topic, right? And that whoever want to consume that particular event, okay, so those people, those services will actually consume those events from the topic, from the event broker, right? And then thereby they can perform the task. Okay, and then they can, so what will happen is they will also produce the event then in this event broker, because the communication, overall communication is happening now in event driven architecture, right? So let's say, for example, when this particular service B will try to send the response to service A, so what will happen is it will again try to produce some other message. Okay, some other message, definitely that will be some other topic. Okay, and let's say it will have, let's say, 101 user name will be there, user email will be there. So that means it will send the user details to this particular service in terms of event only, and this will basically consume this event, maybe some topic, some other topic. Okay, so if you really want to understand what topic is, what message is, right, what do you mean by producer, what do you mean by consumer, so please drop in comments. I'll try to make a video if you really want to get into these details, because I will have to explain those things separately. But yes, topic is something which consumes messages, and then producers produce those messages, consumers consume those messages, right? And consumer also can produce the messages, but the point here is that there will be some other topic, right? Fine. So this is the event driven architecture. Now let's talk about the pros and cons of this particular architecture. So what are the pros and cons? So whatever failures we were facing in this request and response architecture, cons, they will become here pros, right? So fault tolerance. So systems are fault tolerance. Fault tolerance. So this particular first and fourth point are quite similar. So fault tolerance means, let's say, if even a request fails in between, right? If your single request consists of 3 different requests, so if one request even fails, your entire request is not actually failing, right? It's still waiting. Maybe it will try, it will retry, or maybe whatever, but it is not failing, right? So the system is fault tolerant. Now second is high performance, because you don't have to wait for your request to be completed. You can make another request, so your system becomes high performant, right? And loose coupling, less dependent. It is not much dependent. Much dependent means that if some service is really dependent, like if your request is really dependent on this particular service, like whenever this particular service will send you the response, only that particular request will be completed. So it's not that, it is loosely coupled, right? There you had tight coupling, right? What are the cons? Difficult to understand, definitely, because the complexity has increased. You can think of it like, in explaining also the complexity increase, right? So definitely this particular architecture is a bit complex, because it involves a lot of complexities, but yes, it is very much performant and advantageous, right? And debugging and troubleshooting challenges. So this was the difference between request response architecture and event driven architecture. And basically request response model follows synchronous communication, wherein event driven architecture actually follows async communication. So that's the difference, and I hope you have learned something great in this video, right? So that's it from my side for this video, and we will maybe meet in the next video to discuss something else. So that's it, and see you in the next video. Bye bye for now.